This is experiment number 1, that is exploratory data analysis and data pre-processing. Firstly, we read the data set, import pandas as PD and numpy as NP, and read the data set, that is source.csv. Then display the number of rows and columns. So number of rows, df of shape of 0 gives the number of rows, and the number of columns is df of shape of 1. Display the number of categorical and numerical columns. So df.select dtypes is a function which selects whether it is a numerical column or a categorical column. Since it's category, it selects the categorical column, and np.number selects the numerical columns. And we print the categorical columns as well as numerical columns. For numerical columns, we display the min, max, and mean is displayed using LOC. Describe gives the statistics of the statistical summary of the data set. And df.isNull.head gives the columns with null values. Find number summary plot. This is in a box plot. It is given where find number summary plot gives the mean, Q1, Q3, min, and max values. Here, the row index along with outlier values. So we are finding, to find the outlier, we are finding IQR, that is interquartile range, that is Q3 minus Q1. Q1 is the 25% of the data set, and Q3 is the 75% of the data set. The formula for lower bound and upper bound: lower bound is equal to Q1 minus 1.5 into IQR. Upper bound is Q3 plus 1.5 into IQR. So we find the outliers based on the value. If it is less than lower bound or if it is greater than the upper bound, then it has to be printed. And the box plot is plotted for the values, that is quantity. Then the row index along with outlier values and z-score. Z-score is equal to x minus mu divided by sigma, where x is the value, where mu is the mean, and sigma is the standard deviation. So we find the mean using dot mean, and the standard deviation using dot std. We calculate the z-score. So z-score, if it is greater than 3 or below 3, we calculate. If it is greater than 3, then this is the z-score, and less than 3, then we calculate those values also. Z-score is equal to 3 is a threshold to categorize the values. Then we find the correlation between each value. So the correlation between this value, age. So every value like age with age has a correlation of 1. Similarly, for every value, it is 1. But age with other values, you can have the difference. Correlation is how two variables are related. Then the feature pairs with high positive correlation and high negative correlation. To find correlation, we use the function dot core. And high correlation is defined as 0.7, where low correlation is given as minus 0.7. So it is compared, and then it is used if the core and stack is greater than or equal to high correlation, or core and stack is less than or equal to low correlation, then the values are sorted and high correlations are printed. High correlations are greater than 0.7 or less than minus 0.7. Then the feature pairs that have correlation value greater than 60% for the given input features. Correlation is equal to df of features dot core. The threshold is 0.6. So greater than zero point 0.6, these are the correlation, that is price and tax. Then analyzing the skewness of the feature. Skewness is the value to, you can have three types of skewness, that is a right skew, left skew, as well as no skew. It is a statistical measure of how much a data distribution is symmetric. If the tail is longer on the right side, then it is right skew. If it is longer on the left side, then it is left skew. If it is the like no skew, then it is not right skew or left skew. So to calculate this, we're using the skew function. So if skew value is greater than zero point 0.5, it is right skew, or else if it is less than minus zero point 0.5, then it is left skew, or else if it is none, then it is approximately symmetrical. But here the skewness value is 0.3035. Therefore, the value is approximately symmetrical. Then we perform univariate analysis, that is with the city using bar plot and counts of observations. Bar plot is used over here, and univariate analysis is a one variable analysis. A variable city is used over here, and based on the count of the city, we analyze the values. So this is the univariate analysis. Then for continuous variable rating using swarm plot and violin plot. We are performing univariate analysis for swarm plot, as well as uh, perform univariate analysis for continuous variable rating using swarm plot and violin plot. And these are used in data visualization. A swarm plot displays all individual data points without overlapping, arranged along a categorical axis, which shows the exact data values. And a Violin plot shows the distribution of data using a combination of box plot and a density plot. So in a Violin plot, we can see column name rating is given. And here in swarm plot also we have given column name rating. These are the plots. And the scatter plot to show the relationship between two continuous variables. Scatter plot is used to show the relationship between two continuous variables, that is tags and fogs over here. So as the tax increases, fogs also increase. It's more towards a linear relationship. And in bivariate analysis between a categorical variable and continuous variable. So categorical variable is gender and the continuous variable is age. These are the box plot. So we can analyze that the median is here for female and median is here for male, and the min max values differ. Also the Q1 and Q3 differ. Then we perform a bivariate analysis between two categorical variables. Bivariate means we consider two variables, and here the two categorical variables are gender and customer. A bivariate analysis between two categorical variables, that is gender and customer. A cross tab table is used to summarize and analyze the relationship between two or more categorical variables. Count plot is used to display the count of observations in each category of a categorical variable. And here, this is the count, that is the count of male and female. This is how the bivariate analysis takes place using crosstab and count plot. Then we come to multivariate analysis. Multivariate analysis involves multiple variables, that is age, price, tax, ratings, costs, using pair plot. So multivariate analysis requires pair plot. This is the pair plot and the value is city against all other variables. So this is how the multivariate analysis is done. The graphs are analyzed like in a diagonal way. So it shows how the distribution is in the particular graph. Thank you.